Solar photovoltaic decimates wind turbines when it comes to the amount of electricity that is provided by those two sources of alternative energy. And I just want to share this with you today because I thought it was absolutely incredible information that can be put to use in your own thinking on your sources of electricity and how it's generated and from where it comes. And then we'll throw a third component to this, which is a gallon of gasoline, because this is very interesting to me, and I hope it is too. So welcome to the Heritage Wealth Planning YouTube channel, where we go beyond financial planning, like British Petroleum. Now they call them Beyond Petroleum. And they had that scandalous guy, Lord something, who was who looked like George Bush, who was the CEO, was a big wannabe green guy. Man, what was that guy's name? I forgot. But anyway, to be green, he said, we're going to change our name from British Petroleum to Beyond Petroleum, had all his green accolades. And of course, just fell. He fell from glory. And I can't remember what he did, but he got driven out of BP. So we go beyond financial planning. And hopefully I don't follow the same footsteps as that guy. I can't believe I'm drawing a blank this guy's name. That little guy looked like George W. Bush. So I remember that for a fact. And I always laughed at the hypocrisy of it all. All right, so I subscribe to this thing called the Energy Advocate newsletter. And I forgot the guy's name who writes it. Just drawing a blank off the top of my head. It's Howard Hayden. Yeah, Howard Hayden out of Professor Emeritus of Physics at the University of Connecticut. Is out of Colorado, though, Pueblo, Colorado. And you should subscribe too. It's $25 a year or something like that. And just a wonderful source of information on all things energy, not just electricity, but all things energy. And I love it. Every time I get this, comes once a month, I get fired up. Lots of books on the energyadvocate.com. And I imagine I'll probably lose some subscribers when I talk to you about this because Dr. Hayden, he'll tell you the truth about alternative energy. There's just no other way around that. Doesn't mean we shouldn't pursue it. Doesn't mean we shouldn't use it. But just when it comes to maintaining a Western civilization with the level of electricity that we need to keep our comforts of living in America or the West, generally speaking, the facts are solar photovoltaic wind is simply not going to do it. It's just not going to happen. And that's what I love about Dr. Hayden, because not only does he say that, but he says it with the validity of the research behind it. So I want to share you one thing here. It's interesting. And I do want to go on the record. I'm all for photovoltaic. I mean, if you want to get rooftop solar panels, man, go for it. I got no problem with that in the least. I like self-sufficiency. And the facts are with self-sufficiency, if you can keep the lights on when the grid goes down, more power to you without question. That's what I talk about all the time, about alternative ways to make your coffee, alternative ways to light your home, alternative ways to heat your home, alternative ways to keep your fridge on, all that. I'm all for it. If you got photovoltaic, you're wonderful, but that's not enough. You can't just have solar rooftop and say, I'm going to be clear in case the lights go down. It doesn't work like that. If it's grid tied, there has to be a switch in there or some kind of mechanism to turn off the grid so you can go solely on your PV panels with your battery packs. You got to have battery banks or it won't work. Now, the reason for that is because we don't want a lineman going out there and mess around with those utility lines. And then you thought you were on your photovoltaic, and then you turn on your lights, and all of a sudden he gets electrocuted. You can't have that. So if you're grid tied, you got to have a mechanism to go off grid, which means inherently you have to have a big battery bank system in your garage, in your basement, something like that, in order to take the electricity the sun's providing you and put it in your house. And a lot of people, they'll tell me, I'm off grid. I'm like, no, you're not. If you're grid tied, you're not. That simply means you literally are sending electricity back to the grid. That's fine. I mean, I got no problem with that. But in terms of being prepared for the power going out, you are not off grid. You are on grid because it's called grid tied. Now, the technology is increasing all the time to allow you to more easily. I'm not quite there yet. There's a guy who commented on one of my YouTube channel, or was it my blog? I can't remember, but it was pretty interesting. He was talking about how the technology has actually advanced much further than I would have anticipated. So that's cool. But just remember, if you're grid tied and you're looking at photovoltaic, PV panels, solar panels, you got to find a way to turn that off so you can actually go off grid and then go back on grid. All right. So let's talk about what Dr. Hayden says. He calls Wyoming wind. The windiest county in the U.S. is Carbon County in Wyoming. It therefore represents an upper bound for what we can expect from wind energy. It is uncommon to find any data about industrial wind installations for which you can deduce how much power they produce or even expect to produce per unit of land area, usually because the public data do not mention land area. Of course, the area occupied by the towers themselves is a very small fraction of the gross land area because the towers are very far apart. Still, one needs to know how much overall land area would be used in order to produce how much electricity. For years, I've been claiming that the excellent wind sites yield about 5 kilowatts per acre averaged over the year. All right, so he's saying using an excellent wind site, he thinks, Dr. Hayden, that you're going to get 5 kilowatts per acre. A recent AP article quoted verbatim by many newspapers states that a wind project in Wyoming could provide to more than 70,000 homes in several communities in northern Colorado. The unnamed journalist who can't distinguish between energy and power writes, I chuckle at that because you're writing about electricity, but you don't know the difference between energy and power. The Roundhouse Renewable Energy product, which would be operated by Utah-based Enyo Renewable Energy, would use 75 turbines to generate 150 megawatts of energy annually for homes in Fort Collins and a couple other places. Now, we're going back to what Dr. Hayes says. We interpret this confused sentence to mean that the project will use 75 2-megawatt nameplate turbines to generate 150 megawatts in high winds. Another wind project in the neighborhood reports an annual capacity factor of something like 46%, which is reasonable for the windiest county in the U.S. So we might expect the average power output to be about 68 megawatts. The article further states that the project would be operated on more than 45 square miles of private and public land in Laramie County. A simple calculation shows that they expect a year-round average of 2.5 kilowatts per acre. All right. And remember, old Dr. Hayden was saying about 5 kilowatts per acre is what can be generated using wind turbines. But they're saying about 2.35 kilowatts per acre in a very high wind county in Wyoming. The 75 turbines placed on 45 miles squared, 45 miles squared or 116 million meters squared would have an average of 16.7 feet squared of land area per turbine. Average of 16.7 million square feet. Okay, that's what I say. So let me read that again. The 75 turbines placed on 45 square miles would have an average of 16.7 million square foot of land per turbine. With a diameter of 260 feet, the turbines would be spaced about 16 diameters apart. The nearby project is the power company of Wyoming's Chokeberry and Sierra Madre wind energy product, which is under construction. An environmental report about sage grouses, of all things, provides some pertinent data as shown at the left. The important part is the expectation of 12 trillion watt hours per year, which is an average of 1.37 gigawatts. The land area of the project is located in the BLM, which states that Bureau of Land Management, which states that the project will occupy 219,000, basically 220,000 acres. We can now readily calculate the expected average power density as 6.23 kilowatts per acre. That figure is higher than what I quote for excellent sites, but the rating of winds in the Carbon County is superb. All right, so we're going from 2 kilowatts per acre to 6 on the high end, depending on the county and whatnot. So let's just say 5. So Howard Hayden was saying 5. It looks like he's about right. All right, so that's 5 kilowatts per acre. We're just going to throw that out there. Now, basic solar numbers here. I want to run with photovoltaic. All right, so in Atlanta, the sun will average about 180 watts per square meter. 180 watts per square meter. Okay, so what we have to do is, now like right now it's sunny, and the nighttime it's not sunny, and sometimes it's cloudy, you get it. So basically, if you look LA, I think it's 250 watts per square meter, whatever. But in Atlanta, it's 180 watts per square meter. All right, so what we do is we got to look at the efficiency of a PV, a photovoltaic solar panel. And I'm using an efficiency of 20%. All right, so if you say a 20% efficient panel, now some people say, oh, that's too low for efficiency. Not in the common market, man. Yeah, there are some studies that go up to 33% in a lab. Just don't expect that to happen in your lifetime. It's just, in fact, if ever, just don't. But let's just say 20%. I think that's even probably a little bit more. I'm being a little bit more lenient than would be, but let's just use that for an example. 20% efficient solar panel. So we take 180 watts per square meter. Divide that by times that by 20%, which means we'll have 36 watts per square meter, right? So 36 watts per square meter. And I've already done all the calculations, but just hear me out. And what we do is we times that by 24, and we get 864 watt. Basically, the reason you're times it by 20, you're basically getting 1 kilowatt hour per day per square meter of a photovoltaic solar panel. All right. So at the end of the day, if we have an acre of photovoltaic panels laid out in Atlanta, and at 20% efficiency, where that photovoltaic acre of land will give us 145 kilowatts, which is 3,480 kilowatt hours. All right. So again, going back to the acre, if we're going to even use the upper limit of 6 kilowatts per acre of wind, we take 6, and I'll just show you my little thing here. Just lost my, I don't know. I just lost my pen. Let me not go to gas yet. So we have wind. We got 6 kilowatt per acres in Carbon County, Wyoming. We times that by 24, and we're going to get 144 kilowatt hours. All right, 144 kilowatt hours. All right. And that's per day. Now we take solar, and we have 145 kilowatts per acre. Again, that's with a 20% efficient PV panel, photovoltaic panel. That's going to give us 3,480 kilowatt hours per day. So solar decimates wind. It's not even close. And we're talking by a factor of 3,480 divided by 144 of 24 times. So solar is 24 times more beneficial for providing electricity than wind turbines. And that is in a wind turbine in Wyoming versus solar in Atlanta. And solar in Atlanta is not the most efficient, and that is the most efficient wind turbine because that's the windiest county in the United States. Atlanta is not the most sunny county or area in the United States. So solar photovoltaic smoke wind by far. Now, I just want to point out something, though. Gasoline. All right. So gasoline, we have to do a little backwards calculation. So gasoline, if you just look up, there's about 34 kilowatt hours in a gallon of gas. 34 kilowatt hours. So we take 34 kilowatt hours divided by by 24, and we get 1.37 kilowatts in a gallon of gasoline. I mean, just think about that. 1.37 kilowatts in 1 gallon of gasoline. It's just amazing. It's amazing. And for an acre of wind, we get 6 kilowatts. An acre of wind gives us 6 kilowatts, and a gallon gives us 1.37 kilowatts of gas. It just shows you just how just wonderful fossil fuels are. Now, in my house, I use about 55 kilowatt hours a day, all right, in electricity. We also have natural gas, which is our heat source is natural gas. And our stove over there is natural gas as well. And we use our stove, not as much because I do a lot of cooking outside with propane, another fossil fuel. So when you take out our energy or our demands from heating and our demands from cooking, those are all the fossil fuels through natural gas. But that is that's not shown in my my electricity bill, which is about 55 kilowatt hours a day. Now I have a family of 6. All right. I love a hot shower. Our water heater is electric. That could be definitely a big issue for sure. We've talked about this before, but at the end of the day, it's still 55 kilowatt hours a day in this house. So when you think about it, a gallon of gasoline would give us just think about how amazing gasoline is in that tiny little red bucket. You know those little red buckets, those are 2 gallons, those tiny little 2-gallon red buckets. 1 gallon of that will give you 34 kilowatt hours. I mean, it's just amazing how much energy is in gasoline and natural gas. It boggles the mind. And now when you're thinking about it, so solar dwarfs wind, no getting around that. Fossil fuels dwarf solar, dwarf wind. It's just not debatable. Nuclear. All right. So some people hate nuclear. I don't know why. If you're green, nuclear is the best source of electricity there is, but it's just, you can't be beat with nuclear. So the whole point about this is I find this stuff incredibly fascinating, incredibly interesting. And I actually advocate having different sources of electricity or different sources of energy in terms of natural gas to provide you electricity, natural gas to actually use as heat to heat your food, Use the solar. Get a sun cook. I'm a big fan of getting a solar cooker without question. If you want to cook some food and you get one of those solar cookers, I love it. I think it's fantastic. A wonderful way to keep heat outside in the winter or in the summer, because you're heating up your food in a solar sun cooker, which is gathering the sun's ray. I love that. Absolutely. You're not turning on your oven in here, you're not turning on your stove, and so you're not adding to the ambient heat in the kitchen, which spreads throughout your house, and you're keeping all that stuff outside. On top of that, you're not using any fossil fuels. More power to you. I mean, it takes longer, but you can easily get one of those sun cookers. I love it for sure. Solar thermal. If you want to get your hot water, you don't want to do photovoltaic panels, you want to get solar, yeah, absolutely. Use the solar thermal to heat your water without question. Geothermal, all that stuff. I love it. And you should look at it too, especially if you're trying to reduce your electric bills. All right. There are other ways, other alternatives to do it. Now, again, wind is not your friend in this regard. Photovoltaic, if you want to put solar panels on your home, man, I am all for that. Let's just say it costs you $30,000. Are you going to get that back anytime soon? No. I mean, should that be the reason you do that? Is it'll turn around and pay you money? I don't think so, because it's going to take some time for you to do that. You should do it because you do believe you want to get off fossil fuels, which more power to you. I'm not going to qualm you on that or negative you on that. If you want to do that, more power to you. I got no problem. And you say, look, I'm going to invest $30,000 in rooftop photovoltaic panels. I'm cool with the fact that I might not receive a return of my investment anytime soon because I live in a cloudy place or something like that. Hey, man, I got no problem with that whatsoever. Just remember, if you're thinking about doing it as a way to survive the zombie attacks, you got to have a battery bank. All right. You got to have batteries down there that are charging at all times, because that is what will keep you off grid. The photovoltaic panels in themselves will charge your batteries, which is what you'll use to generate the electricity you need to light your home and do all this other stuff as well. Anyway, go to energyadvocate.com. Howard Hayden, I love it, man. If you're at all interested in alternative energy, and I got a couple books by him up there too, which off the top of my head I don't see, but he does the primer on renewable energy, which is fantastic. He's just got a number of books that are wonderful reads that really help you in terms of understanding if you're into this kind of stuff, understanding electricity, energy, power, the whole thing. And then you'll start to see when they see people writing about various things, you'll say, yeah, that doesn't make sense. Like right now I'm on LinkedIn. The guy's posting about in China has all these solar plants, solar farms and whatnot, and just, it's an eyesore. And he said, I went out to China, and he's so green. And I just said, well, how'd you get out there? Because photovoltaic panels aren't going to give you the aluminum or steel or even the fuel you need to get on a plane to fly to China. It's just not going to happen. So if you are trying to go that route, you got to give up the planes. There's no other way around it. And look, I got no problem. I consume fossil fuels. I'm proud to admit I do, because fossil fuels allow us to live in this comforts that we have as a Western society. And I just wish more people in Bangladesh and India and China could witness the same, because having the capability to heat your home, cool your home, cook your food without having to breathe in the firewood, all the crap that's in firewood, which is harming millions of people, mostly kids each year. Man, it's just, it bothers me that so many people in the United States want so badly to be green, but they don't see their brothers and sisters in faraway lands who are breathing in soot and breathing in crap from firewood to heat their homes in China, in these various countries, inside their house. And just that stuff they're breathing in from firewood is just killing their lungs. That makes me sad. All right. Well, anyway, we'll go back to financial planning next time. Just want to give you this little insight into some of the other stuff I read. If you have comments, which I imagine you do, put them down below. If you're an electrical engineer or some kind of physics guy, man, I'd love to hear your stuff. By all means, put them in there. I'm not a physicist. Don't pretend to be one on TV. But I do read this stuff. I'm always interested, and I'm always open to a good debate. I had come across this guy. I was debating this guy on some website I was on, and he invited me to read a book by a pretty liberal physicist in England. I can't remember that book either. I'm losing all my minds here with my books. Experiments with Solar. Right here. No, that's not it. So right here. David McKay. All right, so I get all kinds of books on this stuff, and this is the book, David McKay, and you should get this for sure. Now, this guy's he passed away way too soon, but in terms of a fair reporting of various ways to generate electricity to live in our again Western civilization. You cannot buy a better book, and you can get it for free PDF. But man, you're gonna want to get the hard copy so you can highlight and all that. David, this book is just great. I without question, this should be a primer for everybody. And again, he comes at it more from the green side, more so than an oil tycoon for sure. But I just got just all kinds of books on this. God love it. So anyway, we'll see you next time. Thanks, guys. Oops.